Okay, so for our next example, I'm actually going to do a problem from the assignment. I believe this is slide 10 from this particular assignment. So it says two forces act on a body, so the resultant force is 62.8 pounds. The angles between the resultant and the forces measure 48 and 36. What is the larger magnitude? Okay, and they give you this lovely diagram, which I have reproduced on the side. So there's a couple different ways to go about this. I'm going to show you what I decided to do. First thing that I did is I kind of looked at my diagram and I noticed that this purple force right here is horizontal. So that means that the vector is going to look like A comma 0. Now I don't know what A is because I don't know anything about this vector other than it's horizontal and it makes a 46-degree angle with the resultant force. Okay, now this blue force right here, I'm going to call it F sub R for resultant. Okay, I know that its magnitude oops, is 68.3, and its direction angle with the horizontal is actually 46 degrees. Okay, now this orange angle right here, or this orange force here, okay, I'm going to call it force 1. Okay, I don't know its magnitude, so we're going to call the magnitude as R. Okay, and the direction angle is not 38, it's actually 38 plus 46, because remember your direction angle is always measured with the horizontal, so that is going to give you 84 degrees. Okay, this angle, or excuse me, this force that's the horizontal force, we're going to call that force 2. Again, I don't know its magnitude, but since it's A comma 0, that magnitude will be equal to A. Okay, whatever A is, that's going to be its magnitude. And I know because it's horizontal, its theta is 0 degrees. So what I'm going to do is I'm going to put these in component form. Okay. Okay. So we'll deal with force 2 first. So if I put that into component form, remember my formula is R cosine theta, R sine theta. So that's going to be A times cosine of 0. And then A sine 0. Okay, cosine of 0 is 1. So that's simply going to be A0, which I kind of figured out before, but just to reiterate. Okay, force 1. Okay, that's going to have an unknown in it. So it's going to be R cosine of 84 and then R sine 84. Okay, and then the resultant force, it's going to be 68.3 cosine of 46 and then 68.3 sine 46. Okay, so for the resultant force, I can actually find the component form with no variables, which is kind of nice. So let's go ahead and calculate that out. So for my horizontal value, I get 47.4. And then for my vertical, I get 49.1. Okay. So now I've got a lot of info. Okay, I've got the component form for force 2, component form for force 1, and the component form for the resultant force. So if I recall, that the resultant force is equal to the sum of the two forces acting upon it okay? So we're not dealing with two or more or three or more forces, though there are problems that deal with that. It's actually kind of cool. All right, so force 1 plus force 2 is equal to the resultant force. So force 1 is r cosine 84, r sine 84. Force 2 is a comma 0, and that should be equal to a 47.4, 49.1. Okay, so now if you remember adding vectors, you add horizontal components and then you add vertical components. So we're going to add our horizontal. We're going to get r cosine 84 plus a equals 47.4. Okay, and then our vertical will be r sine 84 plus 0 is equal to 49.1. Okay, now the cool thing about this is if you look at them, you'll see that the horizontal component has two unknowns. It has the magnitude of force 1 and then the magnitude of force 2 as an unknown. If you look at the vertical components, it only has the magnitude of force 1 as our unknown. So we can solve this for r. Okay, so we're simply going to r times sine 84 equals 49. Okay, so we're going to divide by sine of 84, sine of 84. So we get r is equal to 49.4 with rounding. Okay, so now since I have an r, I can use that r in my horizontal component to find my a. Okay, so this one we don't have to do any multiplication or division, we just have to subtract. So we're going to go a is equal to 47.4 minus 49.4 cosine 84 and that gives me 42.7. Oops. Okay, now the question on the slide wants to know what is the larger magnitude. So 49.4 is the larger magnitude. Okay, hopefully this was helpful, and the next videos we make for this section will have to do with navigation, airplanes and boats and things like that. Okay, all right, have a great day.